I'm Angela Yu. I'm a developer advocate with Google Maps platform. Developer advocate and advocacy and developer relations is really about us coming and bringing the APIs out to the developer community to help you get the most out of them, and also to hear feedback from you, to hear what you want to build with our APIs, what they might not be delivering for you right now, so that we can bring that back to the product teams and evolve our APIs to make them better for you. So I'm going to be sharing with you really an overview of what's available through the Google Maps platform, showing you a little bit of demos of like how to tweak some things that are lesser known about the platform. And then my teammate Alex in the back will be following up with another talk that goes a little bit more in depth on data visualizations that you can do with our platform. So a little bit about me. I'm from California. I'm a San Francisco Bay Area native. Grew up with Silicon Valley and all of the .com. And I'm a bit of a generalist. I do web and mobile. And I also have a marketing background as well. So I've kind of played in all of the fields. I've worked in Internet of Things, and that was really where my interest in location-based data was really sparked, and I saw the power and the need for displaying data in a useful way on maps. I've also played with augmented reality, and I worked for about 5 years in voice recognition, where I really learned the constraints of doing user experience design in a very constrained interface where you have only voice and audio to work with. So that's a little bit about me. What is Google Maps platform? It's only the name Google Maps platform is only about 1.5 years old. Before, you probably knew us as Google Maps API. Has anybody made a project with Google Maps API before? Yeah, it's often one of the first APIs that a web developer uses just to get that satisfaction of showing a map on a web page. But that API was released in 2006, so it's over 13 years old. And since that time, when we actually acquired the company Keyhole 15 years ago. We just had the 15th anniversary of that acquisition, and that's what started Google Maps. And then a year later, we released the API officially to support web development using it. And since then, we've expanded and we've grown a lot from that single API to 15 APIs and SDKs. So that's really a lot for the developer community to grok and really understand which API should I use when. So last year, we announced the Google Maps platform that really organizes all of these APIs and SDKs into 3 areas. I'll go into those 3 areas later, but I want to talk about why we went after this whole challenge of mapping the world. We invested in this back in 2005 because we really, as part of organizing the world's information, it wasn't just about bits and data, but it was actually information about the physical world. And in order to do that, we've done a lot to take satellite imagery and really understand what are all of the roads and addresses, what's out there in the physical world. But you think about all of the information we have to collect about the world. It's not just the imagery and the shapes of things, but it's also what businesses are there. What's the status of the river? Things are changing all the time. So if businesses are opening and closing all the time, the shape of land and water and natural features is changing all the time. We have to not only map the whole world one time, but we have to keep updating it and keep that data fresh. So it's a really big challenge. It's a really big challenge to keep up with all those changes. So we have to invest a lot in actually keeping that data fresh and keeping our imagery fresh. And so we've invested a lot in not only depending on local data providers to give us like what they've collected, but actually in collecting the data ourselves. And we've gotten pretty innovative in how we collect that data. One of those ways you may have seen before is a street view. And this is where we designed our own 360-degree cameras before they existed. We came up with this soccer ball looking thing that we put on top of cars and drove all around. And that was one way that we were able to capture imagery of every road, or every road that could be traveled with a car. And then that wasn't good enough for us. So we said, okay, we've got roads, but we want to take these cameras and capture 360-degree imagery elsewhere. So we said, okay, let's take this camera and mount it on other things. We can mount it on a camel, or put it on a backpack so a person can walk around with it, or put it on a tricycle so you can ride around with it and cover more ground. And this picture is actually our boss back there, Mike Pegg, biking the Street View trike in Canada near the Arctic Circle in order to map this area of the world and put it on the map, because he's from Canada, so he was representing his home country. But that's kind of the extent that we've gone. We weren't just satisfied with 360-degree imagery of roads, but we really wanted to cover every surface of the planet. So it's pretty interesting. You can see the URL. Goo.goal is our short link for Street View coverage to see how much we've covered of the world. But you can also just search for really interesting Street View views. You can see underwater views that have been captured. You can see views inside very important places like the Kennedy Space Center, or even these hikes. The backpack wearers have taken them to pretty much every peak, and you can really see fantastic views without ever leaving by just navigating through Street View. And then we also use people, our users, to contribute updates and information about, especially places. The local guides program, we have 60 million local guides all over the world who are actively contributing updates and keeping our data fresh about places, because they really want to make their cities more navigable for visitors and people who want to find interesting places. And so all these contributions, not only from the local guides, but from other sources as well, add up to 25 million updates about places every day. So that's how we're really keeping everything fresh. And then that's not even enough. So we're also using machine learning. You can see here some imagery that was captured with Street View, cars driving in Brazil. And this is an area of the world where we don't have great addressing. We don't have like the exact location of where an address is on a street. And so we were able to use machine learning to do image analysis of the imagery to automatically identify where there might be numbers that correspond to addresses. So it's very hard to spot, but on the right here on the place view, you can see that looking straight on at the building, the face of the business or residence is blocked by a tree. So if you were to only look at face-on imagery, you would never be able to see the house number. But on the oblique, on the left, on the red wall, there's some small numbers right there next to the door, and we were able to capture the address for that residence by analyzing those numbers in the oblique angle in order to match that to say, like, that is exactly the image for this address, or the location for this address. So that all is helping us get really accurate pinpoint data about the physical world so that users can find it, and so that you can use that also with confidence in your apps and websites. So the three main areas of Google Maps platform are maps, which is what you know and love, the imagery, both with polygon imagery, but also photographic imagery captured by satellites and by aerial view, and then also 360-degree with street view. We also have places APIs, which give you metadata about places, and that's much of the details that you might know from using Google Maps on your own, making all of that available through our APIs for you to present details about places that might be relevant to your users. And then routes, as you might imagine, not just getting directions from A to B, but also calculating distances between 2 points or calculating distances between many points, and also information about roads. If you want to present like speed limit data or road condition data, we have a roads API as well. So diving first into the most well-known, our Maps APIs, our Maps JavaScript API is the most popular of all of our Google Maps platform APIs because web developers use it the most. We also offer SDKs for Android and iOS for mobile apps. And then there's other ways that we make it easy for developers to bring map imagery into their apps. With Street View, there's a direct API if you just want to show a particular frame of Street View, like focus on a particular panorama that we've captured. You can easily generate that without having to load without having to load the whole JavaScript SDK. There's also the Embed API, which embeds an interactive map that is tailored to a specific location. And then the Static API, which is the simplest for a novice developer or a very simple use case to include, which is just an image, literally an image tag that we give you this long URL that you can use to embed a very specific map image that you want to present into your website. So something that a lot of developers don't know about Maps, our Maps API, is that you can custom style both for web maps and for mobile apps. Our map styling is defined by JSON blobs. So we offer a styling wizard. I'll show it to you right now. We offer the styling wizard that gives you kind of a WYSIWYG editor in order to tune the exact way that you would like your map to look. So when you incorporate a Google Maps map into your website or your app, it doesn't have to look like a Google map. It can look like your branding, your experience, and it can really reflect the user experience that you're trying to convey. So this is one way that you can create a style. Let's bring over, focus on a map you probably know and love. And this is a pretty messy map, actually. If you're trying to focus the user on data points that are important to you, like if you just care about displaying bike share locations or transit stops, you don't need all of this information. So you can tune down. You can say only show me the main roads or no roads. I like showing some roads so you can see some lines. Or this is too many labels. Let's go in and I'll show you this is way too many other places. They don't care about all these places. So let's turn it down a notch, or no other places. I just want to show my own places. And then you can do the same with labels. You can also do, we have some presets here of monochrome or old style paper map, retro, dark, aubergine. And if you click more options, I'll expand this, you actually have full control over the visibility and color of every type of map feature. So the political boundaries, the natural features on the map, places, what kinds of places, road visibility, and the color of the water. So let's say I want water to be a lot brighter. I'll turn that up. And you can see it automatically updates the view there. And then you hit finish and you get a JSON blob that you can copy and paste into your own code, or a static maps API URL that will give you just exactly that image with that style applied. So there are a lot of possibilities of what you can convey when you apply custom styling to your maps. Moving into places, there are several ways to access places data. We have our web services API, which offers the full set of features and functionality. We also have SDKs we have a places library within the Maps JavaScript API. And then we also have mobile SDKs that are standalone for Android and iOS. One thing that is included in these SDKs is autocomplete, and this is place autocomplete. So you know and love the search autocomplete functionality of like when you go to google.com, you start typing, and it predicts what you're searching for. It's kind of, it's definitely time saving because it saves you characters. It might help you even form better search queries because what you were starting to type, maybe it suggests for you something that is more precise to what you were looking for. Or it could just be entertaining because you want to see what people have been thinking about that topic. This is a really hard problem that Google has put a lot of engineering into solving and making work really well. And what we've done is taken that autocomplete functionality and applied it to places. So we have these widgets that you can just drop into your site that do basically autocomplete for places where places can be defined as a lot of things. It could be businesses or addresses or city names or geocodes. So whatever it is that you're taking in as input, the way that you make this places autocomplete experience work best for your users is by applying restrictions on those predictions. So you can say, you can tell us through the API that you want the results to be only establishments. So they're not going to be getting like city names, or they're not going to be getting like addresses, or on the right side, I've constrained the search bar to return only addresses. So if I start typing like 1, I'm only going to get addresses that start with 1 instead of business names that start with 1. And you can also say only return certain types of places, like only restaurants, or only I don't even know, like only companies. And you can also constrain it by location. So you can say, bias these predictions to locations that are close to my user if I have permission to have the location of my user. Or you can say, I know that this is only going to be used in the UK, so constrain it to just results that are in the UK. And so that really, really narrows down or reduces the number of characters that a user has to type in order to get the prediction that they're looking for. So it's very powerful. The autocomplete for address forms is really something that, like when I learned about place autocomplete, I just thought about it as like a place search tool that I could add. But for companies that have e-commerce, like shopping cart checkout, or if you're setting a delivery point or a pickup point, the address autocomplete is actually very useful because one of the reasons that one of the highest causes of shopping cart abandonment is having to enter in your billing address or your delivery address. That's a lot of fields. It's not copy pastable. So if you put if you put a autocomplete bar, and this is a working sample in our documentation. If you put an autocomplete bar up here, the user can just start typing a few characters of their address, and then select it from their select it from the predictions, and then what you get as the response from the API is the address broken up into components. So then you can take those components and populate the field, pre-populate the field for them, or all the various fields for them. So then they only have to supplement with usually just their apartment number or unit number. Because we, for address logging in Google Maps, we don't get down to the unit number. We just go to like buildings with a latitude and longitude. So that's something to consider if you have address forms in your web apps. We have a few other places APIs. Our most popular one is geocoding API. It's really this utility to convert addresses to latitude and longitude coordinates, so you can easily take an address and know where to place it on a map. Geolocation is a way to get the device or the user's location without using GPS. It relies on cell phone towers and Wi-Fi nodes in order to triangulate where the device is. And time zone API is just if you need to display time, like relative, or make calculations based on the location of or the local time, you can figure out what time zone any latitude and longitude in the world is in. Finally, with routes, our directions API works a lot like the directions experience that you see in Google Maps platform. You specify one origin and one destination, up to 25 waypoints in between, and a mode of travel. We support driving, transit, biking, and walking. And it's really that simple. You can also specify whether you want alternate routes presented or not, and you can deliver all of that through your app. The distance matrix API is another thing that I think is not very well known, but this is really great for when you want to calculate and compare the distances between multiple origins and multiple destinations in order to choose the optimal combination. So if you have maybe a bunch of employees and you need to make assignments of where they should be assigned to go pick up something or deliver something, then you can use the distance matrix API to figure out the distances and travel times of all those assignments and then pick out the optimal combinations. And then the roads API is very useful, especially if you're getting GPS readings off of sensors that are continuously updating, but with GPS, things are not always precise to exactly where they are. So you can use, if it's a moving vehicle, you can use the roads API to snap that point to the road that it's closest to, because you know the vehicle's on the road, even if its GPS signal is saying it's somewhere off in like on top of a building or something. And beyond our core APIs and SDKs, the developer relations team has built a lot of client libraries and utilities in our GitHub organization. So they're all open source, and the sample code in our documentation, as well as more sample code, is all available in our GitHub. So you can explore our GitHub repositories, or if you're thinking about building anything with languages other than JavaScript, we have libraries for Python, Go, and Java, as well as a Node client. So to wrap up, I just talked about our core APIs and SDKs today, maps, routes, and places, but we've also been building solutions for specific verticals. One of the most innovative areas that we've been building for is for gaming developers. So Unity is the main engine that game developers use to create games. So we've been building a set of APIs for Unity developers, or an SDK for Unity developers, to be able to build games based on the real world. So they don't have to come up with and invent all of the buildings and streets for a world. They can just import the actual buildings and streets that are available from Google Maps, and then they can just skin the buildings however they want. Or the other way around, for location-based games, or augmented reality games, or just location-based games, we have a playable locations API that it basically tags like areas that are good for gameplay, so that you can set like spawn points, or say like if they go near any grocery store, that's a good place to get health points. So this is a way that game developers who are developing location-based games can really ensure that their players have experiences that are safe, relevant, and that they can also be in places that are appropriate for meeting up with other players and collaborating on missions. So that's just one example of how we're always innovating and how we're always bringing forward the platform. So if you're building with us, we've got a lot planned for 2020, and so keep looking out for more. So these are the links for how to find us. Our documentation is very extensive, and I talked about our GitHub before. We've been very active with our blog lately, both with tips for developers as well as kind of behind the scenes, like what goes into building all of our maps. And we just launched our YouTube channel, so it's youtube.com/Google Maps Platform. So come check it out. All right, and you can reach me on Twitter. That's the best way to reach me if you have any questions. I'll be here tonight, but if you want to reach out after, I'm always happy to hear from developers. All right, thanks so much.